Okay, then welcome to this talk on domain-driven transformation. I have two questions for you to ask. The first question is there anybody who does understand German? Please raise your hand. Is there anybody who does not understand German? Please raise your hand. Okay, then we will stay in English. And then the other question I have to ask you is, please don't sit down. Please don't sit down. And the other ones, please get up. Everybody, please get up. And now take all your stuff and move to the outside, to the aisle, and come here to the front. Because then I can switch off the microphone and you can still hear me. So please, everybody, please come to the front here. Thank you very much. Okay, und dann kannst du mich ausmachen. Test 1, 2, 3. Absolutely. I will try not to spit too much. Okay. Yeah, thank you very much. Vielen Dank. And actually, I think it's better for everyone if we do not have this lag and this hall in the sound. Okay. So, domain-driven transformation, what's that about? When you look into the program, you see there's a long subtitle that didn't fit onto the slide here. Anyway, it's about bringing architecture or bringing back architecture to already existing software systems, to legacy software systems. I hope my clicker will wake up. Yeah. Okay, so good morning. My name is Henning Schwentner. I have 45 minutes to talk to you, I think. And I'm known as the guy with the many kids in the community. The interesting point is these are all my kids, but they have 3 different mothers. So that means I'm used to live in complex situations. And that's good for what we are going to talk about today, complex situations in software. So much about my private life. I work as a coder, coach, and consultant at a company called WPS, or Workplace Solutions. And as all the companies here, of course, we are looking for new colleagues. And besides being coder, coach, consultant, I'm also an author. You might know domain storytelling, and the upcoming book is domain-driven transformation. That's the topic that we're going to talk about today. And storytelling, I would like to start with a little story today. And where's the story best told? Of course, around a campfire. So please gather with me around this virtual campfire here that you can see. And imagine our ancestors, the cavemen, sitting in their cave around their campfire in the middle of winter. That's hard to imagine. I know it's very hot outside, but do me the favor, please try to imagine it's cold outside, it's winter, the wind is howling, the snow is snowing, and inside the cave it's warm and comfy. But to be honest, it's also a bit boring, so everybody's happy when one of the hunters of the tribe gets up and tells the other members of the tribe how it used to be in the summer when they hunted the mighty bison. Okay. So thank you for coming into this in the middle of my story. Okay, I have to stand here so the camera can watch me. I still hope you can hear me out there. Okay. So the hunter was telling a story about hunting a bison, and this hunting a bison we can still see that today, and that's the interesting point. When you look into the cave of Altamira in Spain, there is a picture painted of this hunt for the bison. And now, 20,000 years later, we still can see this picture, this earliest human art piece we can see there. And what does this have to do with Monolith? Well, we will see that later. It's about storytelling, it's about painting pictures, and those are helpful things that can help us split up existing software, split up monoliths. Okay, so for another story here, for a story that might be more in contact with what we are doing today. Let's imagine Bob. Bob is a victim of Dieselgate, and so he wants to get rid of his old combustion engine car and he wants to buy a new electrical car, but he doesn't have any money. What you can do then is car leasing. And we have this company here called Alphorn Auto Leasing Incorporated, and they're doing car leasing. So usually when you have enough money and you want a car, then you give a lot of money to the car manufacturer, and the car manufacturer will then give the car to you. That's buying a car, right? If you don't have enough money, then we can take Alphorn, our leasing company, in between. And now the leasing company gives a lot of money to the car manufacturer, and the car manufacturer gives the car to the end customer, and then every month the customer makes a small payment to the leasing company. That's called leasing, auto leasing or car leasing, and I think we can all well imagine there is a big monolithic piece of software in place, which is obviously called Monolith, right? Okay, so you were supposed to laugh now. I think that's the Rheinische Frohnatur, right? What we can see here. Okay, so Monolith is an old system, 20 years old, maybe 25 years old. If we're lucky, built in Java, an old system, right? Let's have a closer look into that. This is a C4 model context diagram, and you can see Monolith is not used by the end customer themselves. Okay, sorry. Okay, we also have a lag in the projector. Okay, so Monolith is not used by the end customer themselves, but by a salesperson and a risk manager. So people that are working inside of Alphorn, inside of the auto leasing company. And Monolith is an old system, so Alphorn's boss says, well, this doesn't fit our needs anymore. We need to modernize it, because I read a blog entry about that. And well, the IT department goes on and says, well, what to do about it? How can we modernize it? And they do a smart thing. They hire a consultant, and the consultant tells them, well, the first thing we have to do is we have to understand what's wrong with our system. Where's the problem? So it's a bit like being a doctor looking at a patient and seeing, well, which diseases do they actually have? Which diseases do they suffer from? And what's important here is, of course, that different diseases require different treatments, different medicine, so to say. So what are typical diseases that we find in old system and legacy systems? Well, they suffer from being a big ball of mud. There's no structure in it, especially no vertical structure in it. They suffer from having an anemic domain model. There is no true understanding of the domain, of the Fachlichkeit, as we would say in German, in the system, or not enough. And another disease is bad team organization. Team organization that doesn't fit to the needs of modern software development, how we have it today. So those are typical diseases, and of course the most common case is that the system suffers from all of them. So we have a combination of these things. So the good thing is, I can tell you there are cures for all these different diseases. So there's strategic transformation for the big ball of mud, or against the big ball of mud. There's tactical transformation against the anemic domain model, and there is socio-technical transformation against the bad or not fitting team organization. So we will not have the time today in 45 minutes to look into all these cures in detail, but I will give you an overview so you will get an understanding for that. So one thing is that all these kinds of transformations have refactorings that help them. So we have, let me give this another try. We have strategic refactorings, that's against the big ball of mud. We have socio-technical refactorings, that is reorganization of your team or your teams fitting to the strategic refactorings. And then we have tactical refactorings, and you can see there are two kinds of tactical refactorings. Those against the anemic domain model, those against model anemia, and tactical refactorings which support the strategic refactorings. Strategic things, they are always big, and we want to move on in small steps. So a strategic refactoring is made from several smaller tactical refactorings. So there's a connection here from the tactical against the big ball of mud and the strategic refactorings. Okay. As a companion to the book I was mentioning in the start, I've started a collection of such refactorings. You can find them on my website, hschwentner.io/domain-driven refactorings. When you open that catalog, you will see, well, there are more than just a few. We will not all see them today, but we will get an idea of that. And I want to start with the strategic stuff, with the high-level, big-picture stuff here, because I think that's the problem class that most of us here have to deal with. This problem of having a big ball of mud, right? And the strategic stuff, or the strategic transformation, is done in 4 steps. You can see here. The first step is we have to rediscover the domain. The second step is we want to model the to-be. So with what we know today, how should our architecture actually be? Build an ideal. And then we look at the monolith, at the legacy software, and see the as-is architecture and see, well, how does this fit together? Where do we have to make changes? That's step 3, the aligning the as-is with the to-be. And then step 4, that's the easy thing. Just do the move. Well, of course, that's a hard thing, and that would take a lot of time. So this is the ideal architecture. There is we want to go, and this is the big ball of mud. And well, we have to find this magic arrow to come from here to there. That's the idea. So when we talk about this strategic stuff, about these four simple steps, these 4 steps, at the core of all this lies this here, that we have to control complexity to get a grip on the modernization. So complexity is something that, well, we meet in different areas of software development. There's a famous quote by Bjarne Stroustrup, who said, the most fundamental problem in software development is complexity. And Bjarne Stroustrup is the inventor, the father of C++. And who's a C++ hacker here? Oh, only one hand. Okay, so it's a JCON, yeah, true, but not everybody is young, right? So there's only 2 C++ hackers here. So I was I was trying to make a joke here and saying, well, Bjarne built C++, so he knows about something about complexity. That's funny because C++ is a very complex programming language. It was supposed to be funny, at least. Okay, so controlling complexity, important thing here. Most fundamental problem, according to Bjarne. And Brian Kernighan, also interesting quote, said, controlling complexity is the essence of programming. So what we are doing when we are programming is we want to control complexity, right? And this is where DDD, domain-driven design, comes into the game. And you've seen the title of the talk is Domain-Driven Transformation. And here you can see why. The subtitle of this book, the so-called Blue Book, which introduced DDD to the community or to the world, even is tackling complexity in the heart of software. That's what we want to do here. And then there's a final quote on complexity here, again Straustrup, who said there's only one basic way of dealing with complexity, and that's divide and conquer. And that's something that we have to do on every level, on the small level and on the big level. On the small level, we try to build several methods and several classes, which all encapsulate a small piece or a bigger piece of things. So we can take the complexity and split it up, divide and conquer. And when we talk about the strategic design, we also want to do this on a bigger level. That's where DDD introduces this bounded context and subdomain concepts. Maybe some of you have heard about them. Bounded context, a word that some people know? Yeah, nice. So that's divide and conquer on a bigger scale, right? Than building several classes. So what's the problem with complexity? What's the deal with it? Why is that so problematic? So the main problem with complexity is that we have to fit it in our brain. So this is a complex domain. This is our brain. And of course, programmers, we have the biggest brains on earth. We all know that. But still, even our brains are limited. And even our brains are smaller than the typical domain that we are building software for. So we cannot understand everything at once. And that's the main problem. The typical domain is too big to be understood as a whole. Doesn't fit into our brain at once. And that leads to two kinds of problems here. The first problem are the so-called whack-a-mole issues. And the second problem class are the Max and Moritz problems. What are they? So whack-a-mole is this game that you might know. There's a wooden board in front of you, and there's holes in this board, and then a mole comes out of this hole, and you have a hammer, and you have to hit the mole on his head. And then it comes out of another hole, and you have to hit it. And it keeps coming faster and faster, and you have to hit it faster and faster. And that's the same like working with a big old legacy system. Because you have to make a change to that big old legacy system because you have a new user story or a new requirement. And that means you make a small change here on the system, and then, well, somewhere up here something breaks. That's the mole coming out of this hole, right? And then you fix that broken thing, and then something breaks there, and you have to fix that. And if you're lucky, it stops breaking. But only if you're lucky. Not because you knew in the first place you were not going to break anything. That's the problem with these big systems. That's the reason why it's so much more fun to work with a small system, because you can understand it as a whole, and making a change, the probability that you don't break anything is relatively high. The bigger the system gets, the higher is the probability that you will break something, even with the smallest change. So whack-a-mole issues, one problem class. The other problem class are the Max and Moritz problems. Who knows Max and Moritz here? Many hands. That's good. Max and Morris are two naughty boys who play tricks on the adults. And the first trick is that they go to the widow Bolte, an old woman, or to her chicken, and they bring a loaf of bread, and they tear this loaf of bread into small pieces and tie them together with a thread. You can see that up here in the first picture. And then they throw this bread to the chicken eat it, and you can see what's happening then. The chicken are now connected to each other. They cannot move independently anymore. And eventually they fly up and strangle themselves on the branch of the apple tree. Jedes legt noch schnell ein Ei und dann kommt der Tod herbei. So heißt es hier unten rechts. So it's a special kind of strangler pattern. Finally someone laughing. Thank you. It's a special kind of strangler pattern, not the strangler pattern that we want to really use here. So, and why do I tell you this? Because this is like the teams that are working on one big piece of legacy software. The legacy software is big, it's not structured, so the teams cannot have their own piece of the software, and that means everything they do, well, they are drawing on the other teams. And they are building something and that breaks something for somebody else. So that's why we need boundaries here. That's something that we want to have. That's something that we want to introduce here. Okay, and talking about the strangler pattern, there are different ways of how we can try the modernization of our software system here. That's basically two options: replace or transform. And the classic idea is that replace is possible. So replace would be something like this here. We start with an old system. Those are our users using the old system. And then we start building a new system besides the old system. And while the new system grows, well, the old system has stopped development. It's in a frozen zone or something like that. And then the new system grows and grows and grows, and eventually it is done, a system done. And then, well, we just flip the lever and the users, they use the new system, and then we switch off the old system, and ta-da, we have the new system. This is called, this has this idea of just flipping the lever between these steps 3 and 4, and this is called Big Bang replacement, because like with the Big Bang, wie beim Urknall, like with the Big Bang, there is a new universe here, and everything's nice. I think this name is very well chosen, Big Bang replacement, because what you will get definitely is a Big Bang when you go on like this. But usually this does not work for big systems, because big systems are so big that it takes a long time to develop them, to finish them. So this idea of freezing the old thing, that doesn't work out, and well, this just flipping the lever for the whole system, this also doesn't work out. So a better idea is do something like this. Start with the old system, of course, again, and then build a small part of the new system, and as quickly as possible get our users to use this piece of software in production. So we will feel the pain much earlier. That's the sad news. But the good news is the earlier we get the pain, well, the earlier we can do something against it. And then we move on and, well, we grow the new system, and as quickly as possible we get things into production, into use. And maybe eventually the old system is not used anymore, and then we can just switch it off. Or maybe not. Maybe we stay somewhere there, which might also be okay, because we have already new things here, because we have already new things that can be used. Okay, so this is the goal where we want to go. And talking about stranglers, this is the Strangler Fig application pattern. That's what we want to do here. Strangler Fig, because there's this strange tree in the rainforest in the tropics called a Strangler Fig. And that, well, why is that strange? Because it doesn't start growing on the floor like normal trees are doing. It starts growing in the top. Why and how is that possible? Why does it want to start in the top? Because in the rainforest, or generally in the forest, generally for plants, everything is about the light. You want to be as close as possible to the sun, as want to have as much exposure to the sun as possible. And of course, when you are on the floor in the forest, well, there are all the big trees taking all the light. That's why the Strangler Fig starts at the top. So it has direct exposure to the sunlight from the start. It starts by growing on the branch of a so-called host tree. And then it grows a root to the bottom, and then it goes around the host tree, and eventually maybe it strangles the host tree. That's why it's called a Strangler Fig. And that's the similarity to our software system here. They coexist for a while, and then we want to strangle the old thing. So the lesson to be learned here is, well, Strangler Fig application is a better idea than a Big Bang approach. So if you take nothing from this talk, or only one thing, then take a picture now and show that to your boss when you come back to the project. Okay, when we have modules in our system, or when we move from a monolithic system to a modular system, then we can answer the question, do we replace or do we transform? Or do we buy something? Then we can answer that question differently. When we have a monolithic system, we can just say, well, do this or do that. When we have smaller things, then we can say, well, these two things here, these two things here, we can carve them out, and that we want to build new, and here we want to buy a piece of standard software. And be warned, those are verticals, but from above. So imagine them as pillars. So what we want to do with the transformation is we want to move on from a monolithic piece of software to bounded context, to domain-driven modules in the software. And to find out which bounded context we need, we have to do the first step, and that is this, what I call domain rediscovery. And domain rediscovery means the first thing we have to do is we have to put the monolith aside. So I know we're not starting on the green field. We are starting on the brown field, a very muddy brown field usually. But still, in our minds, we go onto the green field and ask the question, what would the architecture of the software be if we could build it today on a green field? So we have to first clean our mind from all the stuff that we know about the already existing solution and go back to the problem. So in our example, we want to move away monoliths and we want to think about leasing. What is leasing actually? And that means we have to do a mindset switch. So we have to move on as programmers to just being technical people, just thinking about technology. We have to move on to thinking about the business. So we want to become business enablers here. Because we're not building the software for ourselves or for technical beauty, we are building the software for somebody else, for our users. If they can do their job better with the software, then we did our job. So it's about them, not about us. So moving on from thinking about the tooth wheel to thinking about the dollars here. That's what we want to do. And that means we have to understand what they are doing, our users, our domain experts. And there's a family of tools that can help us with that, understanding our users. This family of tools is called collaborative modeling. It's this idea of we do not want to build the model in the software on our own, but we want to build it together with our domain experts, together with our users. That's why it's called collaborative modeling. And there are different methods here. Event storming might be one that you have heard of. Domain storytelling is another one. All of them are lightweight because we want to be able to directly communicate with our users without bringing them much information first. We don't have to teach them the method first. And I'm going to show you an example here for Alphorn, for our leasing company. So we want to understand what they are doing. We developers want to understand what their users are doing, so we are inviting the users into a session and let them tell their story. So we want to hear what they are doing. And so we invite a customer here and a risk manager and a salesperson, because we heard they are all connected to the system Monolith here, right? And then we tell them, well, what is it? What is it that you're doing? And then they tell us, well, I as a customer start with, I'm telling a wish for a car to the salesperson. And then the salesperson calculates an installment for the contract. Installment is this monthly payment that we're going to make. And then the customer signs that contract. And you can see, thinking about this domain rediscovery thing, we're not talking about computers here. We're talking about leasing. We're seeing many leasing words. That's what we want to understand here. And then it moves on. The salesperson passes on the contract to a risk manager. The risk manager will then check the credit rating and calculate the resale value. And based on these values, the risk manager votes the contract. To vote means say yes, we want to do this contract, or no, the risk is too high, we don't want to do this. And let's assume the risk manager votes positively, then the salesperson gives the car to the customer. And here you can see what is still the same for us like for our ancestors, the caveman. We still want to tell a story and paint a picture of that story, because we want to understand what's happening here, and when we want to show our understanding so our users can then say, well, you did get me right, or no, you misunderstood me, we have to do this differently. And with this domain knowledge, we can then move on. So if you want to look into domain storytelling, buy my book, or take one of the booklets that I put onto the exits. When we have understood what's happening in the domain, when we have rediscovered our domain, then we want to determine our to-be architecture, our goal architecture. We want to determine where is it that we want to go. And as I said earlier, especially we want to find boundaries. We want to draw boundaries, because that's something that the system at the time is missing. These boundaries, that's something that we want to draw into. So how do we do that, drawing boundaries? Well, we take domain stories in a special scope. They should be coarse-grained. We don't want to know all the details. They should be optimized. We don't want to digitalize a bad process, because then we have a digital bad process. And we want them to be pure. That means we want to talk about the business. We don't want to talk about how the IT systems are used in the process. We want to look at to the old paper process there. Okay, and then we ask the question, which activities belong together from the point of the actors? So a domain story is made of these actors, that's the stick figures, and then we have the activities, those are the arrows, and we have the other icons, those are the work objects. And we want to draw boundaries around the activities. So together with our domain experts, with our users, we want to find out that the steps 1, 2, 3, and 8, they belong together, and they form what we call a subdomain, a part of the whole domain, a subdomain, and this subdomain is called sales here. And then we have another subdomain down here, which has the steps 5, 6, and 7 in them. And that's the subdomain risk assessment. So we want to find out where are the boundaries in our domain, and that should help us with designing our software systems. We want to take these boundaries and draw them into the monolith as well. Okay? That's this idea of building the to-be architecture. So then we end up with a context map here. So sales and risk assessment, these contexts, we take them out of the domain story, or usually the domain stories that we have. And this context map, that's our goal architecture. That's where we want to go. And here we have only 2 modules. In a real project, we typically have more than that, obviously. Okay, and then we can move on to step number 3, and that is, okay, now that we have the ideal, let's get the monolith out of its box and see, well, how does it map to each other? So we want to align the as-is with the to-be. That's why we look at the context diagram of monoliths again. C4 model has this idea of we come from the outside and look into the components, and let's look into the components of monoliths and let's see if we can find these subdomains there, this sales and risk assessment thing. So when we look inside of monoliths on a container level, then we will see, well, there's a front end and a back end and a database. And they form what we call a layered architecture. The front end is using the back end, and the back end is using the database, and not the other way around. So there is architecture. That's the good news. But probably not enough architecture here, right? Okay, so let's take a deeper look into the containers. What are the components that we find inside there? You can see here, well, the front end is made of 2 servlets, leasing servlet, partner servlet, and there are database tables below here. And in the back end, there is some sort of domain model. We find some domain terms here, which is nice. So a calculator, a contract service, partner service. But what we do not see here is vertical structuring. We see horizontal structuring, layers, but we don't see vertical structuring, modules or bounded contexts. So what we have here is what's called a big ball of mud, no vertical structure. And that's problematic for a big software system because it leads directly to this Max and Morris problems, for example. So let's try to map these 2 ideas on each other. So this is the as-is architecture, and how can we map our context map on this? So let's start with the back end only, because that's hard enough. And let's try to find our context inside of this. So let's start with sales. If we draw the boundaries for sales into the system, then we will see, well, the sales bounded context will use the calculator and the contract service and the partner. Nearly everything of the system. At least they're not using the partner service. And then let's look at the risk assessment. What does this bounded context need? Yeah, well, that uses the partner service, not the calculator, and all the other stuff. So there's this overlap here. And how can we move on from that, from this overlap? That's the big question. And well, we can start with maybe duplicating all this stuff. So we get at least 2 components here, a clear boundary in between. We have a risk assessment system and a sales system. They would still be big, right? But already two pieces of software here. What's the problem? What's problematic here? Well, of course, there will be a lot of duplication. Yeah, really? Will there? To understand that, we have to look even closer. We have to go a level deeper here. And we have to see on a class level, how does this map to our contexts? So on a class level, where do we find sales and risk assessment here? So we have to look into the classes, of course, and here we look at some of the details. In a real system, there would be much more code, of course. So we see in the contract service, there's a sign contract method and a vote contract method. We've seen earlier, well, the customer is signing contracts and the risk manager is voting contracts. And then we can see here, there's a class contract, which has a contract number and signature date, credit rating, voting result, and has getters and setters for all these fields. So it's a data bag here, a dump data bag. All the domain logic is in the service classes. That's what we call an anemic domain model. So we find another disease here as well. So we're not going against the model anemia at the moment. We wanted to go against the big ball of mud. And let's have a look here. Where can we find these contexts here? So sales uses the class contract service and wants to do the sign contract logic, right? And needs a contract with these fields here: contract number, signature date. And risk assessment also needs a contract service and also needs a contract, but you can see different components of them. Different components of them here. Vote contract is part of the risk assessment. The contract number, they need that both. Credit rating and voting result, that's only needed in risk assessment. So if we do this duplication thing, we're actually doing this here. And to get rid of most of the duplication, let's remove the unused stuff. And then we can see, well, the overlap is not so big as we expected in the first place. And that's, of course, typically the case in all of the systems. We do not need all the data for all the logic, of course. And we do not need all the logic for the different bounded contexts. So to go this way, that's what we want to do. And when we clean that up, then we get some nicer, smaller domain models inside of these bounded contexts here, sales and risk assessment there. That's where we want to go. How do we get there? Well, that will take, of course, quite some time. That's why usually it's a good idea to build something that's called a transformation backlog. It's like a product backlog, but not with user stories, only with transformation stuff, with refactorings in the end. And then we will start collecting strategic refactorings like extract the context sales from the big ball of mud and extract the context risk assessment, and then add to these strategic refactorings smaller tactical refactorings that can be done in one sprint. So 1.1, you can see here, the refactoring is called extract specialized contract for the sales thing. And then we want to extract a specialized contract service, and something similar we want to do for the risk assessment context. And maybe these refactorings are still too big for one sprint. Then we have to break them down again and again. And in the end, we want to have small stuff that can fit into one sprint or into parts of one sprint. Because this transformation backlog, that's something that will be beside our product backlog. Yeah. Yeah. Thank you for the question. I'm going to repeat it. Yeah. Thank you for the question. I'm going to repeat that so everybody hears it, and it's also in the recording. The question is, do we have to do this all alone? Is this everything that we're doing? And you're saying I can already hear my product owner saying, well, we need the features and you cannot stop working here. And that's the idea of the transformation backlog, that we have it beside the product backlog. And I'm going to jump over the domain-driven refactorings here and move on to step number 4, do the move. And there we can see how how the idea of this is. So we have the product backlog, and we have features in there, user stories, product backlog items, however you want to call them. And what we now get is, besides this product backlog, is the transformation backlog with strategic and tactical refactorings. And then, of course, we have a sprint backlog for every sprint. And when we plan a sprint, we will not only plan user stories anymore, but we will also plan small steps of the transformation into this. Because we cannot freeze the system, and actually we don't want to freeze the system. But we want to reserve a small baseline, or maybe a not so small baseline, for modernization. Because a transformation like this, that takes years. It will not take days or weeks, and it will not take months. It will take years to do the transformation. And that means you have to do this for a long time. And that means, of course, the transformation backlog will not be done with one short analysis. That's also something that will move on. And then with every sprint, when you have, maybe I start with the first sprint here. We have user story A and user story B, and then say, well, strategic refactoring, and we plan the tactical refactorings 1.2 and 1.3. And in the next sprint, we come with user story C and D and tactical refactoring 1.4. Strategic refactoring stays there because strategic refactoring takes longer than one sprint to be finished. That's why we need the tactical refactorings, the small things here. And maybe eventually we are doing all the tactical refactorings, then we are also done with the strategic refactorings. And so we move on, and then new stuff comes up. And it's a normal, agile, here with Scrum ideas process, right? Okay. Do you want to look deeper into the details now? Then we could go on to the code level. There's one guy nodding, so blame him. No, so I'm going to be quick about that and not look into all the details. But what's important to see is, well, here it can be done, and it can be done in small steps. That's where we want to go. So when we have this contract service and the contract, and we want to extract this method vote contract, then we have to understand, well, what does vote contract need? So it needs the contract number and the credit rating and the voting result. Then we start with creating a new package, or maybe even a new microservice. So the new bounded context risk assessment here. And then we build an empty class contract service. And then we copy vote contract to that. And vote contract will use credit rating and voting result and contract number. And then we will delete the body of vote contract here in Monolith and just call vote contract in risk assessment. You see all small steps, all of them are compiling and running and can be deployed into production. That's the idea of small steps that we want to have here. And then we can remove that here. And we can move on and on and on. I will not go into all the details. Eventually we can throw this piece of code out here. So, and eventually we will be done with the strategic refactorings, and then we end up with the tactical refactorings because we have still an dynamic domain model, right? But sorry to tell you, we don't have the time for that today. So, what's the conclusion here? Of course, in 45 minutes, this looks a bit like this old joke here, how to draw an owl. I hope I have given you some idea of the steps 1A, 1B, 1C here, and doing this in real life, that is quite a task. So that's why Carola and I have written a book about this. But what is important for you today is don't give up. It is possible, and the lesson to be learned here is monolith transformation is possible, and it is hard. So there's one big mistake that you can make, and that is going on the journey alone, doing the mistakes all yourself. It's a better idea to hire someone who already made those mistakes. I could recommend you somebody here at this point. Okay, and with that, I also like to advertise for something good, not only for me, and that is, please consider making a blood donation. After the pandemic, the blood banks are empty, are dried out, literally. Your blood is required. You don't have to look into your arm, and it doesn't hurt so bad. And with that, I say thank you. This is the end. And I will be here for questions, but I don't think we have the time to answer them in the auditorium. So please come to me if you have questions, and I will also be in the hallway the rest of the day.